Okay, so when you look at this expression right here, let's identify the horizontal asymptote first. So based on the rules that we just found, okay, the degree of our numerator is what? We add the multiplicity, so here 1 plus 1 gives us a 2. And the degree of our denominator is 3 here plus 1 here, so 4. When the denominator is bigger, has a higher degree than the numerator, the horizontal asymptote exists where? At y equals 0, right? If you can't divide it, okay, if you can't divide the denominator into the numerator, then you have an horizontal asymptote at y equals 0. Okay, so that would be our answer. Okay, what about vertical asymptotes? Okay, how do you distinguish between vertical asymptotes and wholes? When you look at the factors, cancel any factor, so the x plus 1's cancel. Any factors, any zeros in the denominator that get canceled completely from your equation, okay, are wholes. Any of them that still remain in the denominator are vertical asymptotes. So is there going to be a vertical asymptote here? At what x value? Vertical asymptotes where the factors still remain. So what value of x gives you a 0 for this factor? 9. And so the equation for your vertical asymptote is x equals 9. And any factors that got completely canceled, again, where there's no longer in existence in the denominator, those are your wholes. So yes, there's a hole here as well, and that's at the x coordinate, -1. Okay. All right, let's take a look at this second example here. Okay, so when you look at this rational function, the horizontal asymptote is based on how the degree of the numerator relates to the degree of the denominator. In this time, we have a power of 2 in the numerator and a power of 1 in the denominator. So this means that you can do a division or long division for this. If you can do long division, then the result of that long division is going to be your slant asymptote. So here, there's going to be a no horizontal asymptote. And we'll talk about the slant asymptotes in the next slide. As far as vertical asymptotes go, we need to distinguish between these by looking at the factors, canceling anything that does cancel. So the fact that we canceled all the factors in the denominator, there's no remaining factors that we see in the denominator, so there's going to be no vertical asymptote. Instead, we have the hole at the location of this, again, based on what this is asking. Since there's none, enter DNE in these. And then finally, there is a hole, and to identify where the hole is located, we look at what value of x would give us a 0 in that factor. 2, and it's just asking us for the x coordinate. It's not asking us for the ordered pair, and so we can just identify that x value. And then the final example here, when you look at the degrees of your numerator and denominator, you have x squared, so a power of 2 in the numerator, in the denominator also x squared. So here the numerator and denominator have degrees that are equal. So there is going to be a horizontal asymptote, and that's going to be at the equation y equals whatever the ratio of their coefficients is. So if you multiply this through, 8x times x is going to give you a leading coefficient of 8x squared, okay, with some other terms. Okay, and then here our leading coefficient is going to be x times x, or x squared. So if we take a look at the ratio of their coefficients, 8 over 1, that gives us our equation y equals 8. Okay, vertical asymptotes, we're going to come in, look at the factored form, cancel any common factors. Any factors that remain give us our vertical asymptote. So once again, we are going to have them. This remaining factor has a corresponding 0 at -8. So we have the equation x equals -8 for our vertical asymptote. And then finally, the hole is going to exist where the factor got canceled. So yes, we see there is a factor that was completely canceled. Okay. Now, had this been a power of 2 to start with, where this factor in the numerator canceled with one of these in the denominator, if there was still a factor remaining in that denominator, then it would be a vertical asymptote. The fact that these got canceled completely means it's a hole, and it's located at the x value that gives you a 0 here, which is 9. Okay. And so those would be the answers that you would be looking for.